Thank you all for tuning in to another IDERA ER Studio live demo. Today's topic is documenting a database. Our mission today is to understand the contents of a database, then document it for others to be able to understand. We're going to take three approaches to this challenge. First, as a localized standalone project. Second, as part of a broader data modeling initiative. And third, as part of a data governance initiative. So let's dive in. We need to create a model of two parts: the accepted and approved information of the organization in terms everyone can understand, and the list of data assets, along with technical metadata harvested from the asset itself. We need a standardized understanding of our information. What are the concepts and their attributes? What are our rules and requirements for those pieces of information, such as data types, sensitivity, and applicable regulations? We might also want to understand where the data is mastered, where it is used, and its accountability. We then need to understand the instances of this information in terms of deployed data assets. These assets might be databases, files, documents, or even the data warehouse or lake. We go through a process of analysis of data assets, connecting them to our agreed information model. We can capture data quality information about the assets. Once the model has been built, we can then ask questions, slicing and dicing the model from different perspectives. Which data assets contain this information? What does the data in this asset mean? Which assets containing information about our customer has poor data quality? Hopefully you're comfortable with the idea of logical and physical data models. One side represents the structure of the database and uses technical naming and database product-specific metadata. The left-hand side is the logical, with business-friendly language and business metadata. So in today's webinar, we have three approaches. The first is a simple localized project where we reverse engineer a physical data model direct from a database. The tool generates a first-cut logical data model, and then we elaborate this with business language and metadata. This is the documentation process complete. And as we deliver more and more projects, each of these projects are standalone and isolated. The next approach uses a single logical model that will be common across all projects. So we will have a single logical data model there on the left. This may be an enterprise or corporate logical data model or a canonical model. The process again is we reverse engineer each database, creating the physical model. We may or may not have a local logical model for the project, but that's okay, as the next important step is to map each table and column to the common logical model. And from there, we can do analysis on that model. So from the logical entities and attributes on the left, we can then see what physical data assets contains that information. The third approach uses a business glossary. This is core to most data governance initiatives and is an important part of the ER Studio team server. In this approach, we will map the reverse engineered physical model to business terms. Again, we can then see where used from individual business terms and perform analysis from the business glossary by going through the terms and find where this information is located in the physical landscape. With our agenda defined, let's get started. So let's get started by reverse engineering an existing database. On the menu bar on the top left, let's click File, New, and reverse engineer an existing database. Now you can connect to various data source platforms, including DB2, Hive, Oracle natively, or if we don't support it for syntax, you can always connect via ODBC. But in this case, we're just going to connect to a SQL server using SQL authentication. We're going to define the database here from the database list. I'm just going to stick with the training DB that I have selected here, and I'm only going to include the user tables. Objects that aren't grayed out will be supported for import. By default, all the objects that we're going to reverse engineer are selected. You don't have to reverse engineer everything if you don't want to, but in this case, we're just going to keep it as is. If you're unfamiliar with this database, you may wish to infer keys and indexes in case they weren't defined in the database. In terms of inferring domains, it's often best practice to tick this box. And we'll get to that when we get to the data dictionary side. In terms of the initial layout, we want to choose either circular or orthogonal. And the reason has to do with how the image renders on the workspace. We can always change that when we get to it, but for now, we'll just click circular. You can then choose the type of physical model, whether this is going to be a relational or dimensional. In this case, this is a relational database. If you do have a naming standard template that you wish to apply, you can apply it here. For now, I'm going to delete this and we're going to apply it from the data dictionary so I can show you the scope and different characteristics that you can apply on the naming standard template. And since this is a Microsoft SQL Server, it'll define the data type right here. If you plan on doing this a few more times, it might be a good idea to click Save As here. That way, when you come to this wizard again, all you have to do is simply load these previously saved settings that you can launch again. But for now, we're just going to click Finish. This isn't a very large database. We're going to click OK, and I want to collapse some of these just to show you. So notice that it created two separate data models, one representing the logical and one representing the physical. When working with these models, note that your logical model is database independent and your physical model is database dependent. So by selecting the physical model on the bottom right, we can see that this is tied to a Microsoft SQL Server 2017. If I zoom in a little bit, the first thing you'll probably notice is the syntax for this. Click on this overview. The first thing you'll probably notice is the syntax for these physical models, right? Everything has been abbreviated. Same thing if we come into the logical model. So the first thing I want to do is fix this syntax just a little bit. Before I do that, that way I don't get confused, I'm actually going to rename this physical model to make it more appropriate to our example. So I'm going to stick with trng_db. So coming back to the logical model, zoom in, again, notice that everything is abbreviated. Before we get into the naming standard template, when I inferred the domains, what it did was it took every single column that we reverse engineered and created a reusable column for me. So by double clicking on this, I can see the various metadata for these columns, and any change that I make to these columns or to these domains will propagate to any column or any table that it's associated with. So if I view the domain bindings and make a change to this ADR_ID, you'll see that it gets impacted across these tables in my logical and then these tables in my physical model. And this will also become important when adding this data dictionary to our enterprise data dictionary, because then these domains can be applicable to any other model that we bind this to. So for now, I'm just going to collapse on this because we really don't want to handle any of the domains right now. We're just going to work on the logical model. So right now, under the naming standard template, I'm just going to right click and we're going to add a new naming standard. Now, I'm going to take a bit of a shortcut and actually import that model that was previously defined on there. Now, if we were to have binded this to bound this to our model for import or for reverse engineer, all this would have been done beforehand. But I just wanted to show you again the scope that comes with the naming standard editor. So first we provide it with a user-defined name along with the definition. Under the logical, just as you see within the physical, we can define what kind of case sensitivity we want to have for our objects. So if we want to change everything to upper camel for our entity and attribute names, we can define that. Prefixes, suffixes, again, we can do that with the physical side. With our SQL Server, we want to keep it in the syntax of uppercase, so we'll just leave that. Under the mapping is where we can define our abbreviations. So if we want to take a count and abbreviate it to ACT, we can create a list of these and then make these applicable and automatically change them across our whole model. anything with the general, if there's delimitations there, we can take the characters, find underscores, and then replace them with any character that we want, whether they be special characters. We can take care of, put it to spacing here and replacing with an underscore. And with once our parameters are set, we can click OK. And as you can see, the naming standard template has been applied to our data dictionary. So with this set, we can now apply it to our logical data model. So now we're going to come back to our data model, right click, and come to our naming standards utility. Now note this naming standard template does not apply or does not need to be applied to the whole model. You can apply it to any number of submodels, main models, the whole model. It's really up to the modeler themselves. Because we want to take objects from a physical standpoint and then source them to a logical, we're going to have our sources physical and our target is going to be logical. And because I want to do this to the whole logical model, I'm just going to right click and click select all. And then we're going to run the translation. Now, from the translated name column that we see here, we can take a review or take a list of any of the translated names, and if we're satisfied with them, we can simply click OK and make the changes and apply the changes to our logical model. Nothing has changed in our physical model. We're only sticking with the logical model. And now, with our table and attribute names now digestible to a business audience, we can continue to add more documentation utilizing the attachments and the data security information. So what I'm going to do is we're going to right click and we're going to create a new attachment. I'm going to name this enterprise. So by doing this, what it's going to do is create a folder for me. Attachments are metadata tags. So this is what we can do to tie in tables and columns and give you a better understanding of the scope of how it's being used and where it's being used. So with the folder created, I'm going to create a new attachment and tie this to any number of tables that I wish to tag with this particular attachment. In this case, what we want to do is we want to tag these tables because in the future, we're going to use this as our logical enterprise model, our canonical model. So under this, under the name, we're going to call this enterprise table. And the description is going to be table as part of HR's canonical model. Now the value itself is open-ended. You can define whatever you want, whether it's a generic text list, a text, a time, an external file. But we're going to leave that blank. We don't really need to attach anything to that. But because this is going to be, because this logical model is going to be my enterprise model, I do want to tie it to all the tables that I have defined. So I'm going to check the logical box. Right now we don't see anything. I'm going to come back to that in a second. But coupled with that, on the data governance side of things, I'm going to generate the generic data security information. So if there's sensitive information or if you're in a compliance, you can tag some of your tables and columns, giving you a chance to audit your DB, your database. In this case, since we're dealing with HR, what we want to do is define the privacy level of these as internal use only. Now, these are pre-canned settings. The great thing is that none of these are hard-coded, so you can define them, you can add things, you can delete things from the various text list values that we have. For now, we just want to use that these are internal use only. I do want to define all my entities as internal use only, since this is related to HR. And then just because we're going to imply that there is no security impact on any of these tables. So we're going to check that. Okay. So with those tables tagged, now we might want to think about displaying those. So what I'm going to do is we're going to come here, we're going to right click, and we're going to change the diagram and display option. Now you'll get these little warnings on here that says that these are undoable. You don't have to display these if we want. We're just going to click yes because we just want to change the view here. So right now we're going to add the attachment, not the value, but the data security and the value here. So we're going to click OK. they automatically got resized. So then we're just going to click on one of the layouts here and make this a little bit more presentable. So as we're moving forward, we can see that now our tables are tagged that they're enterprise tables and they have an internal use only privacy level set. So as your model comes together, you might want to think about a few other things. Let me zoom out a little bit. So as your model comes together, we might want to think about grouping some of these tables into what we call business data objects or submodels. So what I'm going to do is take these business data objects, and these are unique to ER Studio, and we're going to create these one by one. So a business data object is simply a container. I'm going to define this as agency. These are simply containers that that we can use to identify tables into their business concept. So agency, we'll click OK there. And one by one, we're going to start compartmentalizing these various tables into the concept that they represent. So there's department. As you add employee, we want to contain the address of the employee, whether they're a contractor, the employee themselves, and whether they're a full-time employee. So we'll click OK on that. And as you add them, notice that they are expanding upon addition to those business data objects. And you don't have to add these like this if you don't want to. I'm going in a different order, so I click 1, 3, 4, 5. That was employee. Let's add skill. Under containment, we want to add skill, employee skill matrix, skill training course. And then finally, on the last one, we'll do training course. And then we'll just define the last two. So just an FYI, only a single table can be tied to a single business data object. So these cannot be shared across across data model, or not data models, but across the model itself. So each one has its own business data object, or each group of tables has their own business data object. So they're really intended to enhance the understanding across a team that may be comprised of business users and technical users. So if I collapse on this, a business user can understand the concept of skill and how it relates to training course, whereas a technical user will come in here and understand how those objects are implemented in the data model. So as I expand on these, we can see that skill consists of employee skill matrix, skill, and skill training course. Same thing with the training course here. And this gives the business users a better understanding, along with the technical users as well. Now, again, you don't have to use the business data objects if you don't want to. Let me move this a little bit, make that a little bit more presentable. Even if you decide not to utilize business data objects, you can still group tables into various methods. Another one is submodels, which can prove very useful when handling larger sets of data. This just says that I am tied into team server and that I have 428 terms. So as I click OK, I can start adding submodels, and this will give me various windows into the model as a whole. So what I want to do is just replicate what we had with the business data objects. So I'm going to add agency, and I don't have to do this on a one-by-one basis. I could do this on a massive scale. We're going to do department, and I want to add department into that table. And as I start getting more and more or bigger submodels, I can use control click or shift click. I'm going to hit address, employee, full-time employee, contractor. We want to add another submodel. We'll call this one skill. So again, there's skill, employee skill matrix, skill training course. Then we want to add our final one, which was just training course. Now, unlike the business data objects, the multiple tables can exist within multiple submodels. So in my business data object, I only had training course and training history, but I can also add the other tables in there, right? So skill is not only in training course, but it's also in the skill submodel. So when I click OK under the data model, now I have my various submodels. So I have my main model, which contains my business data objects. And then I have my various submodels. You can zoom in a little bit, show the model as a whole. Same thing with department, same thing with employee and skill. Let me click model here. Any of the changes that I make to my submodel will propagate to my main model in terms of metadata. The only thing that doesn't change is the display and the diagram and display option. So if I was to come and change the diagram and display option to show any of the data types, as you can see, these are all car, dates. Under the main model, those still stay the same. Oops. Same thing if I was to change any of the colorations. I want to set the color. I like choosing ugly colors because they kind of make things pop a little bit. It gives you a better understanding of, or gives you just a little bit of pop to your model. Under the main model, everything is still white. So nothing has really changed there. And these are just a few ways to help help modelers and business users understand their model. And again, modelers can take this idea, the reverse engineering, the adding of domains, adding of attachments, changing the naming standard, applying this across your model and making things consumable. They can replicate this process across multiple projects to further define their data assets. And as they do this, they can simultaneously map this to other physical models. So what I want to do is from here, log into my repository and add this into my repository so that we can map this to other physical models. So now that I'm logged in, no errors occurred. I want to use this time to add this diagram to my repository. Provide it with a name. We're just going to call this one. This is HR database enterprise logical. So this is like as I mentioned, is going to be part of our canonical model. This is where we're going to map to other physical models. So I have my name defined in here. I can associate it into a project, which is simply a collection of databases within our repository. And then if I wanted to promote this local data dictionary to enterprise. So as we built those attachments and data security tags and your various naming standard template, you can take that and then promote it to an enterprise data dictionary. And then as you add models to your repository, you can then bind it to said model so that you can apply the domain, those reusable columns or the naming standard, and apply that to other models, standardizing on your repository set. And then finally, under this, we want to checkbox the auto-publish diagram. And we'll see when we get to the team server the importance of that. So note that the models stored in ER Studio are version controlled. So we see now that there's this little blue padlock icon to the right of our tables. So in order to map these, a checkout is necessary. So what I'm going to do is we're going to check out the diagram. So during the checkout, in order to make these changes, you can optionally add comments or change records. Oops. I'm going to give it a change record of universal mapping, and we're going to provide it with a name. Oops, map table, can't type. And we're going to click OK. So by adding these change records and text document the changes made, it's definitely a recommendation to help documentation purposes to see who made what changes and when they do this. And as you can see, the padlocks are now displayed in green to confirm that these are a successful checkout. So we can map these in a couple of different ways. The first way would be if we right click, we can run the compare and merge utility to run an automatic change for us. So I do want to proceed with the changes. In this case, what I want to do is I want to compare it against another object in our repository. So I'm going to browse our repository and compare it against this physical employee data model. Now, it's going to ask me to check out the model, which I can click OK. I do want to compare it against this employee database physical model that's associated in that model. I'm going to leave these defaulted. These are simply the options that we want to compare against. And then, as you can see, these are all the objects in the model on the left, and then the target is the objects on the right. So once I get here, I want to leave all these to ignore because I don't actually want to merge the changes. I just want to map them together. So what I'm going to do is I'm going to check the box to save matches. And we want to make sure that we click synchronize mapping changes to the repository so that when we finish, it'll simply just merge those changes. And by clicking finish, it'll save the changes to my model. We do want to continue. Now we're going to hit close on this. So now if I was to come to employee, double click on that, we can see under the where used tab that under the universal mapping, this logical entity is tied to the employee database in the physical employee diagram. So another way to do this is a manual process. So if we wanted to, we can right click on the employee and simply run the universal mapping utility. So on the center window here, we can see our currently open model. So we see that it's a logical model. I do want to filter on these two objects here, the data architect diagram and the entity table. So we're going to leave those checked. In order to make the map, what I want to do now is select the model that we want to map this to, along with the physical model that we want to map this to. Can expand this a little bit. And because we have employee selected, let's just select employee here again. Now with these selected, you can see a little edit icon. This will give you some additional definitions or notes that we can add in here for additional metadata. Any attachments that we want to add, but we don't really have any, so we're just going to check that. Click OK. And rather than double clicking on the table, we can then right click and run the universal or the where used tab, I'm sorry. And now we can see that employee has two different universal mappings, one for the employee table in the physical employee diagram, and then for the EMP in the physical skills diagram. So now they're pointed to two separate data models, and we can click OK. And before we do anything, I just want to check this. Actually, let me do it from here. We're going to check in the diagram. We're going to add the change record. Note that the mappings themselves are bidirectional, so that if you do go into one of the other physical models from the repository and open up that EMP table, you'll be seeing the mapping back to the original logical model, which is the one that we have open right now. And now there's a little blue padlock icon. So not only can these be tied to tables, but these mapping can also be created against individual attributes or columns. So not just the entities or tables, and it provides a different level of granularity. So with that being said, not only does it show it from the data architect side, but then it'll also document it in the team server aspect or the team server web portal as well. So I'm going to click on the team server tab here. The diagram itself will manifest itself in two different places. I do want to refresh this tree because I just added this in there. It'll manifest itself in two different places, under the ER tools and the ER objects. So it'll manifest itself in two parts of the tool. So what we want to do is let's come back into here and let's just, because there is a search bar, we can simply navigate from here. And I want to enter the name of the model that I just reverse engineered. So here's the HR Enterprise Data Model. And I want to click on my logical side because I wanted to go into, notice that under the ER objects, this gives you all the metadata associated with the object that we're looking at. So within my logical model, I did create a handful of submodels. It does have a handful of entities along with relationships in here. What I want to do is I want to click on employee. And now we can see the metadata for the particular object that we have selected. So again, there are the attributes. These are what I had reverse engineered, and this is what we've been editing. We can see the universal mappings and where they're located or what they're associated with under the universal mappings tab. But coupled with that, we're starting to see the effects of adding these the attachments and the data security in our data model. So under the attachments, we can see that this is an enterprise table. By clicking on the enterprise table, we can see the definition, which is just a table as part of the HR's canonical model. But furthermore, we can see the attachments or what enterprise table, what they're bound to. So the enterprise table, as part of the canonical model, contains department, full-time employee, training course, address. So it's indexing things in the team server to make things easier to navigate. And if you're unfamiliar with ER Studio Team Server, this is a web-based tool where you can access, search, edit, manage your enterprise metadata. So as I mentioned before, under ER tools and ER objects, they'll manifest, or the objects will manifest under those two places, where they exist in the repository. But coupled with that, this team server allows you to manage additional metadata, such as the glossaries and terms or other data sources. So here's where we're going to take a look at adding our predefined business terms and map them to objects in our data model. So under the terms, what we want to do is, because we're looking at employee, let's just stick with that. Under employee, we can do this in a couple different ways. There is a search bar here and at the top right. Everything does index alphabetically as well, so we can come back to E and just search for things that have employee. We can open up employee. All the terms that you see will have the same tabs on the left here, so we can take a look at the stream. What changes have been made, who made those changes, when they made those changes. So we can see that the admin modified this employee with a new value here. And then we can see, of course, just the scope of things that have occurred from here. The user-defined description, which contains the definition, the alias, the abbreviation, some additional notes, stewards on the right-hand side, and who created it. Just a collection of metadata for historical purposes and just a user-defined description. Under the discussions, you can actually use the portal to create topics and discuss any issues or any agreements that you might have with said term or glossary or object, right? So the discussions are available on all the tabs throughout the team server portal. Any related glossaries, the employee is part of human resources, and since we reverse engineered and we added the human resources or the HR logical model, this is dealing with human resources, so we're going to stick with employee. Now, employee does have a few related terms associated with it. in particular address, number, type, just some different definitions that we can apply. In this case, what I want to do is open up employee number. And we can see that it's just a unique identifier for an employee. Under related ER objects, when you get to the terms, you can see what objects are related to the term itself. So under the employee number, which was that unique identifier, we can see all the various aspects or all the various metadata that's tied to this employee number. So we have a few things: EMP ID from the pubs document, from our demo document, from our HR database physical employee. So what I want to do is take this employee number and actually relate it to the table that we just uploaded to our repository. So I'm going to come in here and we're actually going to search for EMP, because we want to search for EMP. Now I do see it in a couple of different tables. So notice that these are tables, relationships. Of total EMP, there's 490 objects that contain this search filter. I want to whittle that down. So I'm going to look at the column information. So under EMP, I can see that it's associated in all 62 columns here. Let's get more granular. I want to include underscore NMB. And just like that, I was able to take the search and then whittle it down to 5. I want to just stick with, I want to relate this to this training database. I don't want to do it to any of the other columns from the full-time employee tables or anything. I want to associate it within this training history table. So I'm going to click relate here. So now if I go to the column, just like I had before, I have my general description, which contains all the metadata from the table, from the column that I've uploaded into my repository. It tells you what submodel it's associated with, some additional notes. But along with that, there's this breadcrumb navigation of where this exists in the scope of the whole model. So employee number is a column that's located in the training history table that's part of the training history physical model, that's part of the HR database enterprise logic. So I want to take this opportunity to follow this breadcrumb navigation and open up my physical model. So from my training DB model, I want to look at all the tables that I have in here. So from the training DB, you can see I have the ADR, the agency, departments. Let's open up EMP, because we want to start building off of that. So EMP is going to represent employee. Again, I have all my columns, all my indexes, the DDL for this table in particular. I could, if I wanted to, come into the related terms, see that it's not bound to anything, and potentially relate it to employee. So if I come and look for the terms, I find employee and I relate it there. So now if I come to related terms under the view, I can see that employee is related to this business term employee, or the EMP is related to this business term employee. Going back to EMP table, I can take a look at, I can open up my columns and look at employee number. From the employee number, just as I did before, I'm going to look, find out that there's nothing, there's no terms associated with this, come back, relate my employee number now. So I'm going to click, or I'm going to search for employee, scroll down a little bit. We're going to relate this to employee number. So now if I look at employee number, and everything is via hypertext, so I'm just moving back and forth. I'm not using any navigation here. I'm simply clicking and following the navigation as it's presented to me. So under employee number, I can see the related ER objects, and now that I've associated them in there, I can see that this one HR, which is the one that we initially reverse engineered, is associated with this employee number. So now the column is classified against this term, and we can view that anytime we open up any of these terms. And it's important because as your repository grows, the use of business glossary and terms becomes paramount. As as it defines not only the data vocabulary across your enterprise, but it's ensuring consistency in your business terms. It basically synthesizes all your details about an enterprise data asset across multitude of your data dictionaries across your organization in an easy to read format. So with that being said, this concludes another IDERA ER Studio live demo on documenting a database. In summation, we were able to successfully reverse engineer and elaborate a localized project. We promoted the local project and implemented it on an enterprise level. And finally, we mapped that data asset to business definitions in the ER Studio Team Server web portal. With that being said, I highly recommend visiting the IDERA website to download and trial your own copy of ER Studio Data Architect and Team Server. For more information, you can visit our contact page at idera.com/contact sales.